Good morning, Algebra 2 students. This is Mrs. Bigelow teaching from her living room. Um, and I've done a couple Algebra 1 videos, so I'm getting a little bit more confident with it, but go easy on me this first few times. I sent out a text to all of you guys that, of course, homework 88 and 89. Those really, 88 should be turned in by tomorrow. It is graphing and it's from RenWeb. And then the decay and growth problems. For those of you who weren't here on Monday, I'll post another video on that real quick because it's not hard. Most of that homework is not RenWeb. I think I said RenWeb. I didn't mean RenWeb. I meant Desmos. So on homework 88 and 89, most of your work is going to be on Desmos. I don't want you guys to just do the graphs and sketch them without learning what is happening to the graphs with, adding a number to the outside, adding a number next to the x, what makes it go right, what makes it go left, up and down. I want you to make your homework. I haven't given you a lot of problems. So I want you to do those Desmos, and I want you to make observations about what is happening. Okay, because that's really what is going to be important as far as your final goes and as far as those going on to pre-cal. But today I'm actually right on track as far as the calendar goes, as far as RenWeb. But again, I told you I would extend all homeworks out 3 days. So that means the homework that I assigned on Monday is due tomorrow, and then 88, that would have been the one I would have assigned yesterday. That will be due on Tuesday, and homework 89 on Wednesday. For some reason, my lesson plans, homework 90 would be due Thursday. So by next Friday, I want to be all done with 8.1 to 8.3, and I will have a quiz up. I gave it to you, but I'll give you more on that. But by next Friday, I want everybody to have finished homeworks 88 through 91, and I want the quiz finished. Alright, so you have lots of time. It's only going to be a few videos, 3 or 4 I think actually only 3, but anyway, so keep on track. If you have contact with Guyon or Jaden, or Sam Cordera, those are the few that haven't gotten on, but other than that, you guys are all on Google Classroom, so job well done. Before I start, I hope you guys are all doing well. I know some of you are probably going stir crazy, not having your sports, not having your activities, not being able to get out and do things. So I'm just praying for you. I am just trying to keep up with everything, all the new ways of doing stuff, so I'm pretty busy, but I can see that it could probably be pretty hard for you guys if you're used to being really active. So anyway, that being said, I'm just going to pray, God, just please help my teaching to be really, really clear right now and help the students to focus. And this is I think, a pretty fun concept, but I know most of you guys don't think so. How could math be fun? But I encourage you to just have an open mind. So we're just going to give this time to you, God, and just pray for all of us to stay healthy and safe. And we just pray for this coronavirus pandemic to be over soon. In your name we pray. Alrighty, so we are on page 446, and we're going to talk about logarithmic functions. So it is section 8.3. I'm going to go for a little darker font. Let's see. Just playing with this thing. There we go. Logarithmic functions as inverses. So what exactly does that mean? Well, let's pull out what we do know. We know what a function is, right? Two requirements of a function. Input-output table. Each input can only have one output. And the vertical line test. So, and we talked about not functions. We talked about inverses. When you flip the y and the x, and you've seen what that happens as far as what happens to a graph when you graph a function and when you graph its inverse. So we're going to extend this to a concept called logarithms, and this is the definition, and this is key to today's lesson. The logarithm, and this will not be on a notebook quiz. Just because I say that doesn't mean you shouldn't concentrate on this, because this you really need to know how to use this formula to change an exponent into a logarithm and vice versa. Okay, so the logarithm to the base b of a positive number y is defined as, and this is the part that is really, really crucial for you guys to understand as we go through this next few sections on logarithms. If y equals b to the x, looks familiar, right? Then log base b of y equals x, right? So, how do we apply that? Say I ask you to write this expression, actually equation, sorry, 25 equals 5 squared in logarithmic form. So, if we look at these two right here, I can say that my y is 25, my b is 5, and my x is 2. So y is 25, b is 5, x is 2. Okay? Does everybody understand that? Okay, if this is the case, which we know that to be true, right? Then the log base b, what's my b? Log base 5 of 25 equals x. Pretty cool, huh? Okay. Let's do another one of those. Say I have 729. Oops. So 729. Oh, that's really bold. equals 3 to the 6th. My y is 729. My b is 3. And my x is 6. Then that means logarithmic form is log base 3 of 729 equals 6. One half to the third power equals 1/8. Means my y is 1/8. My b is 3. And then my x is 1/2. Wait, that's not right. So b is 1/2, x is 3. So this is log base 1/2 of 1/8 equals 3. Okay, one more. 10 to the 0 equals 1. 10 to the 0 power equals 1, which means 1 equals 10 to the 0 power, which means y is 1, b is 10, and x is your exponent, x is 0, which means log base 10 of 1 equals 0. Okay. Okay, so we're going to switch this up, and we're going to flip this, and we're going to make it that we are given, scratch that. I want to evaluate log base 8 of 16. So we're going to flip exactly what we did. We're going to go from, we're going to flip the statement that I gave you earlier. We're going to say if log base b of y equals x, then y equals b to the x. So I just flip-flopped what I gave you earlier. Okay, so if I want to evaluate log base b, like log base 8 of 16, I want to make that